Okay, the last video for chapter 1 is about inverse functions on page 17 and 18. Now you can find inverses, but you can only use the function notation with a little -1 up here to indicate that inverse is a function when it is a function. So if my function says A goes to B, then the inverse says B goes to A. So very simply, if these are my x's and these are my y's, and you can see this is a function because no y's repeat, I interchange the x and the y. And interchanging the x and the y, I now have the inverse function. And notice none of the y's repeat, so I was able to call it a function. So now with this cubic graph, it's your basic cube. I've plotted it. And when you learned how to graph the inverse of a cube, you were always told just to inverse the ordered pairs. So I did, and I plotted them. And that's what the inverse is. Notice if the original function's increasing, the inverse is also increasing. That's just the way the game is. If the inverse is decreasing, if the original's decreasing, then the inverse would be decreasing. Now, how do we find an inverse algebraically? We interchange the x and the y since we are looking for an inverse. We solve for y by undoing order of operation using the inverses of each. We denote the inverse of a function, if it is a function, as f inverse, h as h inverse, etc., but only if it's a function. Now my first one. Here is the original, so what am I going to do? F of x is really a y, so I just want to make sure you understand that f of x is the function form of the y coordinate. So I interchanged my x and y, and I'm solving for y. Well, what's order of operation? It would be cube, multiply, subtract. Cube, multiply, subtract. So therefore, I need to undo subtract, which would be adding. So I add 2 to both sides, and now I have x plus 2 equals 1/2 y cubed. Again, I'm solving for y. What's order of operation? Cube, multiply. Last thing out of my mouth was multiply, so I need to undo multiply. And I will use the reciprocal of 1/2, which is 2. So I multiply both sides by 2. Now I'm down to y cubed. How do I do the inverse of a cube? I undo cubing by cube rooting. So I have the cube root. So this is my answer. Notice a cube, positive stays positive, negative stays negative, 0 stays 0, so it's a function. So the inverse of f of x equals 1/2 x cubed minus 2 is the cube root of 2x plus 4. Now, please note that I'm using function notation. What if the inverse is not a function? Then you cannot use function notation. You just have to leave it as y equals, or you need to restrict its domain so it is indeed a function. So, I'm going to give you something that's a function, but its inverse is not. So again, the f of x, I rewrite the f of x as y. I love the new TI Inspire because when you are a function, it'll give you the f1, f2, f3, f4. But the minute you have to do something that's not a function because the y's repeat a relation, it won't let you use f of x. You're forced into using the y key, because y lets you be a function or just the larger group of a relation. So now I interchange the x and the y, and I'm solving for y, so I see square, multiply, add, square, multiply, add. So the last thing out of my mouth is add, so I use the additive inverse. What is the additive inverse of a positive 1? Is adding -1 to both sides. Now I'm still solving for y squared, so I see square multiply, square multiply. So now I need to use the multiplicative inverse. What's the multiplicative inverse of 3 is 1/3. Now in a minute I'm going to tell you you could have gone ahead and said divided by 3 and written this as x minus 1 over 3. That's perfectly legal, but I'm sticking with the multiplicative inverse, which is truly 1/3. And so now I'm down to y squared. I square. How do I get rid of a square? I square root. But what do we know? An issue arises. When I have an even root, remember, blah squared equals number squared means blah equals plus or minus number. So what do I have to insert here? A plus or minus. Wow, now it's not a function because the y's are going to repeat for a given x. So it's simply a relation, the larger group. Remember, a function is the relation is the big group and the function is a subset. So now I could write this and say, oh yeah, this is an inverse, but I can't say it's an inverse function. I can just say, yeah, it's the inverse of y equals. Okay, but what if I want my inverse to be a function? Then I can restrict the domain. So let's say that originally I wanted x to be greater than or equal to 0. I'm restricting the domain. But when we trade places, we reverse x and y, so anything that was a y becomes an x, and anything that was an x becomes a y. So now I go ahead and I see that, oh, my y's need to be positive, so I don't want plus or minus, I just want positive. And so now, under these restrictions, this indeed is going to be an inverse function. I could have restricted the x's to being less than 0. Again, trading places. What's going to happen? My y becomes x, my x's become y's. I still have the square root, but now my y's are restricted to being negative. And so, again, now I can use function notation. And down here was my note reminding you this could be x minus 1 over 3, x minus 1 all over 3, x minus 1 all over 3, and here x minus 1 all over 3. So endeth your notes on chapter 1. We just have to get to chapter 2 now.